So this video is going over the test for review. So let's proceed. For this first question, number 1, it says the measure of angle C is equal to an equation and the measure of angle D is equal to equation. Find X, the measure of A, and the measure of B. So we're given C and D. So those are those two angles right there. So they are a linear pair, right? So what we're going to do is we're going to add those together. 2x plus 13 plus the 6x minus 9. And we're going to set them equal to 180 because a line measures 180. So that's going to give us 8x plus 4 equals 180. And then when we subtract the 4 from both sides, that's going to give us 8x equals 176. And then we're going to divide both sides by 8. So x is equal to 22. Now it's asking us for the measure of A and B. So let's find the measure of angle C. So the measure of angle C, isn't that equal to the measure of angle A? Why? Y'all see an A right here? They're vertical angles, right? So vertical angles are congruent. So to find that, we're going to do 2 times our 22 plus our 13. That's 44 plus 13. So that's going to be equal to 57 degrees, right? So then when we're asking for, and it's asking us for the measure of angle B, isn't that going to be equal to the measure of angle D? So the measure of angle D is equal to the measure of angle B, again, because they're vertical angles. So here we're going to do 6 times 22 minus 9, and when we do that, we get 123. Okay, so once again, remember that how we solve for this is we solve for this part up here because they were a linear pair, right? And how we solved for the angles on the bottom was that they were vertical angles, right? Okay. So number 2 is a proof, and it says using the bank, fill in the blanks. So it says that we're given that AC is congruent to BD, and we're trying to prove that AB is congruent with CD. So we're going to work down through this each step. So our first point is given here. So this is our given information. So that is AC is congruent with BD, right? So once I get that AC is congruent with BD, I'm going to mark through it over there. Then our next step, the only difference, oops, I forgot to put the congruent symbol there. The only difference between the first step and the second step is that there's an equal sign instead of a congruent sign and the mark's over top, right? So this is going to be the definition of congruence. And I'm going to put a symbol there instead of writing out that word, okay? So we've used that one. Then it says subtraction property. So what's the only thing on the left, y'all, that has subtraction property as a step? It's this one right here, right? So that's going to be AC minus BC is equal to AB. So we'll mark through that one. And then what do you notice in step 4? It is the subtraction property. So this is the subtraction. I'm just going to write subtraction. Okay, prop. Okay, then reflexive property. What does reflexive property mean? It means the same thing as on both sides of the equal sign. So we're going to do BC here is equal to BC, right? That's that step right there. And then what is the only thing that's left? So, and why is it the transitive property? Because above we have that AC is equal to BD, AB and CD, and then BC is equal to BC. So if we say AB is equal to CD, it can't be anything but the transitive property, and the choices you would have here would have been reflexive, symmetric, and transitive, right? And the reflexive property is the same thing on both sides, right? The symmetric property, things flip sides when it's segments like this, and the transitive property means you have two unique things, okay? So then the definition of congruence down here again is what we're trying to prove. AB is congruent to CD, segment CD, okay? So we used everything. And by the way, you need to study all 3 of these proofs because one of them is guaranteed to be on your test, okay? So let me see if I can move this down just a tad so we can see that angle. Okay, there we go. All right, this time it says, these are actually segments too. It says AB is congruent to BC, AD is congruent to DE, BC is congruent to AD. Prove that DE and AB are congruent, okay? So, again, we're given some given information here, right? So this is our given step, because those pieces of information are there and there, right? Then we have the transitive property. So what do you notice is repeated in the step above? Do y'all notice the BC and the BC? So for our next step, those are going to drop out. So we're just going to have AB is congruent to AD. Then we have our given step again. So we have some more given information up there, right? So let me mark through these. So that was AB and AD right there. And so then this is another piece of given information. So that is AD is congruent with DE. That one right there, right? So then notice above, what do you have repeated again? Do you guys notice we have an AD and an AD? So that's going to drop out. That's what gave us the AB is congruent to DE. So this is our transitive property again. Okay, and then again, what are we trying to prove? DE is congruent to AB. All right, our third proof is saying given that angle XZW, YZW, that angle right there is congruent to XZV, right? So, and it's saying prove that these two angles then are congruent. The two angles, this outside angle right there and that outside angle out there. Okay, so the first statement is given information. So that's going to be YZW is congruent with XZV. Okay, so that's our given information. So YZW, XZV. Where is that? X, is that X? Wait. YZWXZV. Yeah, anyway, that was our given information right there, okay? And then the only thing, again, that changed between the first step and the second step is the definition of congruence. Okay. Then we have the subtraction property. So do y'all see this right here? That's the only thing up there that has subtraction, right? So the measure of angle YZW minus the measure of angle XZW is equal to the measure of angle YZX. So that's our subtraction property. And notice step 4 is subtraction property as well, right? Okay, so we've got the definition and the subtraction, right? Then it says reflexive property. So reflexive property means we have the same thing on both sides of the equal sign, right? So isn't that going to be this one right here? So the measure of angle XZW is equal to the measure of angle XZW. So what we did was we subtracted this angle right here from this angle and that angle. And the red and blue angles, originally it told us those were congruent, right? So what does that mean? That means that the resulting angles have to be congruent, right? So this is what property then? This is the transitive property again because we have 3 angles. Okay? And then what are we trying to prove again? So that would be again angle YZX is congruent to angle WZV. Okay? So one of these 3 proofs is going to be on your test, so make sure you study them, okay? All right, so the next one says, state which theorem was used to solve each of the problems. So I noticed that this has 3 congruent sides, so that means it has 3 congruent angles. That means I'm going to do 180 divided by 3. Each of those angles is going to be 60 degrees, right? So if it's telling me that angle E is 7x plus 11, can I just say 7y plus 11 is equal to 60, right? So 7y is going to be equal to 49. So y is going to be equal to, divide both sides by 7. I subtracted 11 from both sides to get the 49, and then I'm going to divide both sides by 7 to get 7 here, okay? Now, with 3b, it says find x in all the angles, okay? So we're going to use the exterior angles theorem for this one. You need to know that. Okay, so we're going to add angle L plus angle M. These are the remote interior angles to get our exterior angle. So we're going to do angle L plus angle M is going to be equal to the angle ONM. Okay, so that means we're going to do 4x plus 2 plus the 2x minus 9, and that's going to be equal to the 5x plus 13. So this is going to be 6x minus 7 equals 5x plus 13, right? So that means we're going to subtract the 5x from the 6x. That's going to leave us x, and this is going to be x is equal to, add 7 to both sides, so that's going to be 20. So now I'm going to solve for the measure of angle L. That's going to be 4 times 20, that's 80, plus 2, so that's going to be 82 degrees. Then we're going to find the measure of angle M. That's going to be 2 times 20, that's 40, minus 9, so that's going to be equal to 31 degrees. Let's keep going, and then we're going to find this exterior angle, which is the measure of angle ONM, and that's going to be equal to 5 times 20, that's 100, plus 13, which is 113. And by the way, if you add 31 to 82, you get 113 as well. And then this interior angle, this angle right here, how would we find it, guys? Couldn't we subtract 180 minus 113? And that would be 67 degrees, right? So that's going to be the measure of angle LNM. LNM. That's that interior angle. Y'all got me? So that it's a linear pair with the exterior angle. Okay, then it says EG bisects DEF. So I'm going to create a DEF here. DEF, and it says EG bisects it, right? So that means this angle is congruent with that angle, right? So DEF, I think I changed this on the review, didn't I? Did I not change it? Oh, DEF. I think this is supposed to be DEG, y'all. DEG and GEF, yeah. So this is supposed to be 6x minus 6. And this is supposed to be 2x. Let me see how I did it on my paper. Yeah. It's supposed to be DEG, y'all. So this was 2x plus 22. Okay, so we're going to set those equal to each other because they're congruent, right? 2x minus 6 is equal to 2x plus 22. So subtract 2x from both sides, that's 4x. Add 6 to both sides, that's 28. Divide both sides by 4, so x is equal to 7. And then we're going to plug that back in. So 6 times 7 over here. So let's go ahead and plug it in right here. 6 times 7 is 42. 42 minus 6 is 36. Okay. And then again, 2 times 7, that's 14. 14 plus 22 is also 36. And then it's asking us for the whole big angle, DEF, right? So don't we have to do 36 plus 36 to get the whole big angle? And it's 72 degrees. Okay? Then it says choose all the answers that apply for the two transformations that are the same as one rotation. So on this one, I'm going to work through each of these individually. And I'm going to start with 180, y'all. I remember that when I do y and x and y, this is 180. So that's 180. I'm going to color code these. Okay, then we've got x and y here. Then also remember, if we have y is equal to x and y is equal to negative x. Doesn't matter the order, okay? But when I have both of these, those are all 180s, okay? So then when we start talking about reflections over the y-axis, and then y equals negative x. So this one is going to be a reflection over y and then y equals negative x. And then reflection over x and y equals x, okay? And then the next one is going to be reflection over y equals x and then the y-axis. Are you seeing some patterns here? Okay, you should be. Okay, then the last one is going to be reflection over y equals negative x and the x-axis, okay? So then our last one is this one, 270 and 90 clockwise. And some of y'all missed this question on the last test because you didn't notice the clockwise. So you got to watch for clockwise or not being there. So these are the only ones that are left. Y'all got me? So once again, look through these, and you guys by now should have these down pretty cold. So I like to memorize the 180s, and then the rest of them I can work through, okay? And you can do that, again, remember, by doing a point in the rules. So what is the reflection over the y-axis? Actually, let's do it this way. What is the rule for the reflection over the x-axis? It is x comma negative y, right? What is the y-axis? That one is negative x comma y. And then a reflection over y equals x, you just flip them, right? So it's going to be y comma x, whereas a reflection over y equals negative x is going to be negative y comma negative x. And you can do this with a point and then just check it, okay? So number 6 says, in the diagram to the right, ABK is that angle, and the measure of JKM is there. Okay, so those are the two angles they give us. So it says find x. So what theorem are we going to use here? We're going to use the corresponding angles theorem, right? What does it mean when they're corresponding angles? It means they're congruent, yes? So, and you can tell they're both acute angles. So remember, if you got two parallel lines, and we can tell that because they both have those red arrows on them, right? So if they both have the red arrows, then we know that those are parallel lines. So we're going to set these equal to each other. 7x minus 6 equals 4x plus 12. We're going to solve for x here. So subtract 4x from both sides, that gives us 3x. Add 6 to both sides, that gives us 18. Sorry, that's supposed to be an equal sign right there, y'all. Then divide both sides by 3, so x is equal to 6. So that's the first part of our problem. Then it says find BKL. So what is the relationship between these two angles right here, y'all? Aren't they vertical angles? So we're going to say the vertical angles theorem, right? That's the theorem we're going to use. Okay, and then what do we do here? Don't we have to solve for this one right here? We do. So what is that? That is JKM. So we're going to find the measure of JKM because it is equal to the measure of angle BKL, right? So let's just do that. 4 times 6, 24, plus 12. This is equal to 36 degrees. Okay? So the next one says find for each example, find the indicated angle measure, then state the angle theorem used. Okay, so it's asking us for the angle EBC, which is this angle right here, right? Okay, so we have angle ZYB. And what is the relationship between those two angles? They are same side interior angles, right? They're on the same side of the transversal and they're inside the parallel lines, okay? Same side interior angles, okay? So what do we do with those? They're not the same shape, right? So they are supplementary. So we're going to say 6x plus 3x plus 9, that equals 180, right? So that's going to be 6x plus 3x is 9x plus 9 equals 180. We're going to subtract 9 from both sides. So that's 9x equals 171. So how many times does 9 go into 171? 19 times. So this is 19. Then to find the angle that we're looking for, remember we're looking for this guy right here, right? So the measure of angle EBC is going to be equal to 3 times 19 plus 9. Well, that is 66 degrees. Okay? All right, so now I need y'all to hear me here because we have done this proof before and it is on the test again. So we're going to walk through it. So it says AC is parallel to BD. AC is parallel to BD, so I'm going to mark that on the drawing. AC is parallel to BD, okay? Then it says that we're given an auxiliary line. So basically drew the auxiliary line to make this proof. So step 2, if you remember, led from that, right? So we made this line. So what are we going to do now? We're going to add the three angles together, 4, 2, and 5, right? So we're going to do 2, 4, and 5, and they're going to equal 180 because they are a straight angle, right? So the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equal 180. And why do they equal 180? Because they're angles of a straight angle. Okay, they're angles of a straight angle. Okay, then we have alternate interior angles theorem. So what is the first pair of alternate interior angles we see? Again, we got a parallel line there, and then we got a transversal right there. Y'all see it? So can't we say that the measure of angle 1 is congruent to the measure of angle what? 4, right? So that's the statement right here. Then we're going to make a statement on the other side that is similar, right? So right over here, y'all see that other transversal? So we're going to say the measure of angle 3 is congruent, I'm looking up here, to the measure of angle 5. Why are they congruent, guys? Because again, they're alternate interior angles. So the alternate interior angles theorem. Okay? And then what was the reason for the last step? We were able to substitute in 1 for 2. No, so wait. Let me say that. 1 for 4, okay, and 3 for 5. So 1 for 4 and 3 for 5. Okay, so this is the substitution property. So once again, you need to know this proof because it is on the test. This exact proof on the test, okay? Now this one, we did these in our notes earlier this week. So then this one we're going to actually say again, where do we get our first 2 steps from? It says, given FG is congruent to DG, and G is the midpoint of EC. So this is given information, as is the next step, okay? Then it says the definition of a midpoint. It says G, right here, is the midpoint of this, right? So if it's the midpoint, don't we know that EG is congruent with CG, right? Okay, so we know that EG is congruent with CG, right? Isn't that one of our steps? EG congruent with CG, right? Okay. Oh, let me mark out our givens up here too. Given, okay. Then it says these 2 angles are congruent. EGF. So EGF, this angle, is congruent with DGC, right? Why are those angles congruent? Because they're vertical angles, aren't they, y'all? Okay, I'm just going to write vertical angles. Then it says side angle side. So that means we have a triangle congruent statement, right? So I got a triangle that's congruent with a triangle, right? That's what side angle side means, is that something's congruent with something. So let's check these statements up here. So we got 2. So we got EGF, EGF. Okay, so if it was EGF and we went across that one tick side first, then it should be what? CGD. So it's definitely not that one. And we've only got one other one, so let's check it too. So this one is FGE, so FGE. So we went across the side that didn't have a tick, right? So that's DGC. So that is our statement, right? So this is going to be triangle FGE is congruent to triangle DGE. And then our last statement is we got triangles are congruent and we're trying to prove parts are congruent, right? So this is CPCTC. That's what CPCTC tells us, right? Is that parts are congruent because the triangles are congruent. All right, so here's our next one. MN and EN, it says right here is given, right? Then it says LN is an angle bisector of MNE. So this is another piece of given information, right? Here again. So then it says definition of an angle bisector. So it's telling us that this angle right here is bisected by LN. So what does that mean? Doesn't that mean that these 2 angles are congruent? It does. So we're going to say angle LMN is congruent to angle what? LEN. So we just used that right there, right? And we did use our 2 givens again. Given. Okay. Then it says the reflexive property. So we were given that MN is congruent to EN, right? And then, y'all, can you see that this is a shared side, right? So we can mark that, right? So aren't we going to say LN is congruent to LN? That's a reflexive property when they have the same thing on both sides, right? So now, look at our top triangle up here. This triangle right here, y'all see it? Why is it congruent to the other triangle? See side, angle, side? Got it. Okay, and then once again, so we did use side, angle, side. And then what was the reason for us being able to say that a part of the congruent triangles is congruent? Again, 3 C's, P, T. Okay? All right, so this next one says, what can you mark on the triangles to show show congruent sides or angles? State your reason for the congruence. So the first thing I notice is this right here, that angle ACB is congruent with angle ECD. And again, notice I started out here, so I'm starting out here, okay? And those are congruent because they're vertical angles, okay? So that's what we can mark. There's some other things that we can mark more, but we're going to go ahead and start with this. And then it says, if you want to prove the triangles are congruent by angle side, what congruent statements would you use? Okay, so if we want angle side, okay, so we need another angle, don't we? So I'm going to mark this angle up here and that angle down there. So I'm going to say angle A is congruent with angle E. Why? Because they're alternate interior angles, okay? So that's the reason, okay? Then it's another angle, right? So we're going to write the angles that we already wrote. So angle ACB is congruent with angle ECD. And we already said that's why, because they were vertical angles, okay? Then where's our side? Okay, so here's our side right here, right? So if we say BC, BC is congruent, that was given information, right, to DC. Got it? All right, now the next one says, if you want to prove the triangles are congruent by angle side angle, okay, so now we already had that was marked there, right? So now we want angle side angle. So this time, I'm going to go down here and I'm going to mark angle B is congruent with angle D, because we want the side between the angles. So I'm going to say angle B is congruent to angle D, and then I'm going to say my side now, right? So I'm going to say BC is congruent to DC. Those are sides, right? Okay. And then I'm going to say my other angle. And this time I'm going to do my vertical angles again. So angle ACB is congruent with angle ECD. So notice here again we have an angle and a side and angle, right? Up here, what do we have? An angle and a side. So now let's write a triangle congruent statement. And I'm always going to start this in alphabetical order, this left side. ABC is congruent with what? EDC. Okay? All right, so the next one says, what can you mark on the triangles to show the congruent sides or angles? So here again, we can mark that shared side, right? So we're going to say XZ is congruent with what? This time we're going to say ZX because we can't move across that side the same direction, can we? Okay, and what property would this be? Wouldn't this be the symmetric property? Okay. All right, then we're going to mark some things up and we're going to say why we can mark them, okay? So then on the next one it says, if you wanted to prove the triangle is congruent by side angle side, what congruent statement would you use? Okay, so I would need this angle up here and that angle down there, wouldn't I? Because I got a side and then an angle and then the side. Okay, y'all see that? So I'm going to say angle W or side WX has got to be congruent with what side? YZ. Again, start it outside here. If I start W here, I got to start Y there, okay? And then where's our angle? So this is going to be angle WXZ. Cannot name that with one letter. Got to name it with three because I got three angles up there at X, okay? And that's going to be equal to YZX. Why are those congruent, y'all? Because they too are alternate interior angles, aren't they, y'all? Because we have these parallel lines out here. Y'all see this? Okay. And then what is our other side that is reflexive property? So that's going to be XZ is congruent to what? ZX. And that, again, would be reflexive property. Okay. So then this next one says, if you wanted to prove the triangles are congruent by side, 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 what additional congruent statement is needed? Okay. So what additional statement? We'd have to have this one, right? That WZ is congruent with YZ. So I'm going to say WZ is congruent with YZ, right? Wait a minute. Did I say that right? No. WZYX. My bad. YX. Okay. Then I could say XZ is congruent to ZX, right? And what was our third side? WX is congruent with YZ. And again, what do we have? side, side, side. Now we're going to write our congruent statement. I'm going to say XWZ, WXZ, WX, WXYZ. Yeah. WXZ is congruent with what? YZX. Move in the same directions again across those triangles, okay? All right, so what can you mark on the triangles to show congruent sides or angles? Again, we got a right angle right there, right? And we got a shared side there. So we can say that RT is congruent to RT. And what property is that? That's the reflexive property, right? And we can also say that angle STR is congruent with angle QTR. Why? Because they're a linear pair and one angle is 90. So the other one has to be 90, right, y'all? Okay, because 180 minus 90 is 90. Okay, so it says if you want to prove the triangles are congruent by side angle side, what congruent statement would you use? So look, we've already got everything marked that we need, right? So can't we say that ST is congruent to QT? That's your one tick side down there. Then we've got angle STR is congruent with angle QTR. And then we're going to say that side RT is congruent with side RT, right? All right, then it says if you wanted to prove the triangle is congruent by HL, what additional congruent statement is needed and what would you use to prove HL? So wouldn't we need this, which is the hypotenuse, and that, which is the hypotenuse? So we would need that SR is congruent to what? QR, because those are our hypotenuses, right? And they are both right angles, so that's our first condition, right? They are right triangles. We got two right triangles, right? That's our first condition. And then we could use either one of the other sides. So we could say ST is congruent to what? QT. Okay? So this triangle statement, congruent statement, again, I'm going to do RST. So what would be my congruent statement for the other side? RQT. You got it. All right, so this last one says what two rigid motions map triangle ABC to DEF? So A to D, right? Then we've got B to E. So I would say a reflection over the, can you all see the reflection over what? The y-axis. Can everybody see that? Over the y-axis. So, because it's going on the other side, right? But if it did just reflect, A would be right there, so that would be my D, right? So what else had to happen? So if I moved from A to D, how far up did I have to go? 1, 2, 3. So I also had to go 3 up, right? Everybody see that? Okay, now this one over here, again, we're mapping A to D and B to E. So do you guys notice that this was vertical and now it's horizontal, right? So what do y'all think happened there? So I would say it probably rotated, right? Can you guys see the rotation? How far did it rotate though? So let's look at A. So if we were to rotate A, which is 1, 3, 90 degrees, because it looks like it rotated 90 degrees, right? Then what would it become? So wouldn't it come down here? So remember, if we do a 90-degree rotation, that's negative y comma x, right? So what would that be? So wouldn't that be negative 3 comma 1? So that would be negative 3. So I don't think it's a 90-degree regular rotation. What if it was clockwise, y'all? So let's try clockwise. What is clockwise? Clockwise would be y comma negative x, right? So that means that now that would stay a positive 3 and this would be a negative 1. That looks like it might be it, right? So let's do 3, negative 1. So that would now be our, so that was A that we rotated. So that's going to be D, right? So there's our D. And so how far did D move from there? And we could do that with B as well, right? So if we wanted to double check it, so B is 1 comma 1. So this would be what? B would be E. So E is, DE would be -1, 1, right there. So that would be E. So then what did it move? 1, 2, 3, 4, right, as well, right? So this was a 90-degree clockwise or 270-degree rotation, right? Which would, and also 4 right. That's it.